All right, so I'm going to work in Chapter 4, number 14. Attracted by the possible returns from a portfolio of movies, hedge funds have invested in the movie industry by financially backing individual films and/or studios. The hedge fund Giltstar is currently conducting some research involving movies involving Adam Sandler, an American actor, screenwriter, and film producer. As a first step, Giltstar would like to cluster Adam Sandler movies based on their gross box office returns and movie critic ratings. Using the data in the file Sandler, apply k-means clustering, so that's what we'll be doing in the data mining, with k equals 3 to characterize the 3 different types of Adam Sandler movies based on the clusters on their variables ratings and box office. So that'll be the 2 items we use for the variables. Now the rating corresponds to movie ratings provided by critics. Higher score represents a movie receiving better reviews. The box office represents the gross box office earnings in 2015 dollars. Now we want to be sure to normalize the input data, specify 50 iterations, 10 random starts, and step 2 of the Excel miner k-means clustering procedure. And then we're going to use the results to characterize Adam Sandler movies. All right, so hopefully everybody has already got their password and login to their analytics solver if they're using it on the web, or if they've already downloaded it for their PC using it in Excel. It doesn't work in a Mac for PC or a Mac for Excel, so a Mac definitely has to use this version. PC users can use this version or download it for their Excel. But this version is better in one sense in the fact that you can go anywhere, and as long as you remember your login credentials, you can do any computer on campus or friend's house or whatever to do your homework. And if you have it only on your computer, you have to be sure to take that with you. All right, so first thing we need to do is open our source. And it said it was Sandler, so we'll open that. Next, we have to go, and what it does is it shows us our title, our ratings, and our box office, basically revenue in dollars. 2015 dollars for that matter. And so we go to Excel Miner, and we're going to do clustering. So we want to do k-means clustering. Let's overwrite. That's fine. And so this is all found in Appendix 4.2 in our book. It's about k-means clustering with Excel Miner, and it's something that, you know, it steps you through the processes that I'm kind of doing now, but if you need to look through as you go, it's a good thing to do. And so that's something you can get out of your book, and it really helps. So we're going to do ratings, and we're going to do box office dollars. Okay. And that's all we need to do on this one. And we want to make sure we have first row contains headers. That way it knows that. Next. All right, I said to normalize the data. So let's normalize the input data. It said we wanted k equals 3 clusters because we want to cluster his film into 3 types. And we want to do 50 iterations. We want random starts. We want 10 random starts. So I'll just arrow up for 10. And in the book, it says we need to set the seed to 1, 2, 3, 4, 5. So it's already set, so we don't have to worry about that. Next. It's going to show the data summary as an output as well as the distances from each cluster center. So that's fine. Let's finish. Now we can go down here and see that it's doing the k-means clustering, processing, processing, processing. And now it's loading results for us. And it gives us results over here. Okay. Now instead of reading it here, let's go ahead and say, let's download it. So now let's say we want Sandler, say download. Open with Excel, that's fine. And so now while that's loading, what we're going to have to do is go and do a new share here. Yes. And so now hopefully you'll be able to see this. And okay, what happened there? All right. So this is our what we just downloaded. So it has our first tab is our data. Second tab is one set of outputs. And the third tab is the last form of outputs. So really what we're looking for is the clustering itself. So we kind of go down here. We're not really worried about the random start summary. We're worried about cluster centers and data summary. Okay. So let's first kind of look at our cluster centers. So first, this is the original coordinate. So this is going to tell us a little bit more because it's going to tell us, the cluster ratings, the cluster dollars. And so that's going to be more important because looking at the normalized coordinates for these ratings and the dollars really doesn't tell us anything, but this one does. So this one shows us cluster 1 has the lowest ratings, okay? And it also brings in the lowest box office revenue, okay? Now, cluster 2, that's kind of the mid ratings, but notice it brings in the most box office revenue. So it has the highest revenue is the mid cluster. And then the highest cluster rating gives kind of the mid cluster dollars as far as it doesn't give us anywhere near cluster 2, and it's a little bit higher than cluster 1. So that's kind of how the clusters are working. Lowest rating to the highest rating, and this is like the lowest dollar, mid dollar, and then high dollar, okay? So the next thing we need to really look at is the original coordinates aren't really good to look at the distance between clusters, and that's what that is, distance between cluster centers. And like I said, the normalized coordinates aren't really good for looking at the actual clusters as far as what do they mean, because we really need those dollars to make it make any sense, because we can kind of see the same thing here, but it's not as intuitive as the regular dollars. But now when we look at this one, normalized clusters, that's what we need to do, looking at the distance between the centers, okay? And so what we can say here is, this is the between cluster distance centers. And so the largest distance between the centers is going to be here. That's the largest distance. That's between cluster 2 and cluster 3. So those are the most distinct clusters. And then the next closest is between 1 and 3. Okay, so it's just a little bit smaller, so it's not as distinct as cluster 2 to cluster 3. And then the least distinct, I guess you could say, would be the cluster 1 to cluster 2 at the 2.03. Okay. So that's kind of that part of it. Now we can kind of go down here next to the data summary. Now, in the original coordinates, that's probably going to be the best one because as far as what we're going to look at now first, and what we can see is cluster 1 has basically half of the movies. Because the total is 48 movies, half of them, 24, are in cluster 1. Then we have 15 of them in cluster 2, and we have 9 of them in cluster 3. So that's the lowest rated, the mid rated, and the highest rated. And that's kind of the average distance. And that part really doesn't tell us anything. But if we go to the normalized data, that really tells us something. So the number of objects in each cluster stays the same, but now that average distance is really what's telling us the most. Now the smallest average distance is going to be the one that's the most homogeneous cluster at all. So it's kind of everything's all homogeneous and it's right all together, and that's cluster 1. Now, then on the opposite end of the spectrum, although this one is very close to each other, is the 0.74. That's the highest average distance. And so that's the most heterogeneous cluster because it's kind of the most spread out. And so that's going to be what we can get out of this information here. Okay. The next thing is if we go to the KMC clusters, that's going to tell us some more information. So here we can look at each actual sample. So if we go over here, sample 1 shakes the clown, that should be record RD number 1. And it goes into cluster number 1. And what this is this kind of shows us, okay, it's cluster 1, so that's kind of telling us the cluster distance here. So let's see if we can spread that out a little bit. All right. So, so what basically tells us what each cluster belongs to and how well the observation fits the assigned cluster in relation to the other clusters. So when it's the smallest and furthest away from the other clusters, that's the best. Now let's first look at one that kind of really distinctly fits that, and that would be, say, cluster 13. So it fits into cluster number 1, and it has a very small distance, and basically it's saying it's very close to the centroid of the center of that cluster. So it's very close to that center, whereas it's not very close to 2 or to 3. So it's really far distant from those, but it's very close to the center of that one. So that's kind of the ideal situation, is they all are really, really close to one cluster, but really far away from the others. Now, cluster one, or record one, which is in cluster one, it's kind of not that nice. It's close to, cluster one with the centroid. It's 1.1. But if we look over here at cluster 3, it's only 1.46 away from the cluster centers for cluster 3. So these two are closer. It's still in cluster 1, but it's not too far away from that cluster 3. So that's kind of how we can see how these clusters fit together. This is pretty close to that one, but it's still really far from cluster 2. So we don't really have to worry about it. It's just the one, it's closer to the cluster 3. So that's kind of what we can get information from our k-means clustering. And again, the key items we're looking at is cluster centers, data summary, and then this one, this is just kind of for your information to kind of show you how distant they are, distances from the cluster centers for each cluster and where they fall, and then how far they are from each of the centers of the different clusters. So hopefully that will help you understand the k-means clustering and how it works, and how to use the analytics solver in actual a browser window, and then download it and upload things to and from it, and hopefully that'll work. If you have any questions, though, please feel free to contact me. Thank you.